Welcome to Digital Adhyapak.
Now the question that we have today is show that the square of any positive integer is of the form 4q or 4q plus 1 for some integer q. Dear students, there is a thought behind this question, so we will understand that process first and then we will solve the question. See students, we have to show that square of any number is in the form 4q or 4q plus 1. And as you know that any number can be written in the form of Euclid's division lemma, or it can be written in Euclid's form, but the form will depend upon the divisor. What divisor you take, that will show the number's exact form. Now check. Suppose it is being written that we have to find out the square of a positive number, and then we have to show it in the form of 4q or 4q plus 1. Now students check, if we take 4 as the divisor, so definitely we will get 4 numbers, that is 4q plus 0, 4q plus 1, 4q plus 2 and 4q plus 3. And for all those 4 cases, we have to prove that when we square the number, it comes in the form 4q or 4q plus 1. Now students, if we take the divisor 4, we have to show 4 cases. But to make it easy, to make it less time consuming, at place of 4, I will take the divisor as 2. Why 2? Because if we take 2, we have only 2 forms of a positive number. One is 2q and other one is 2q plus 1. Now the question here is, sir, if I take 2, then can I get 4 common out of there? Yes. When you square the number which is in the form of 2, then 2 square will be 4. So definitely you will be able to take 4 common out of the expression after squaring it. So students, this is the trick that you have to keep in your mind. The same question could have been solved using 4 as a divisor also, but in that case the question would have become lengthy और आपको 4 अलग-अलग cases दिखानी पड़ती. But if we take the divisor as 2, ये question छोटा हो जाएगा और 2 cases में ही आपका जो काम है वो पूरा हो जाएगा. So let us start. Let me divide the board. Now let us start. See, it is written, show that the square of any positive integer is of the form 4q or 4q plus 1. So first of all, let us suppose that a be a positive integer and 2 be the divisor. Fine. So according to EDL, that is Euclid's division lemma, a is either equal to 2q plus 0 or a is equal to 2q plus 1. As I have to bring it in the form of q, so in place of q I should take it m here, so that there should not be any confusion. So I will write a is equal to 2m plus 0 or 2m plus 1. Now in both the cases I have to show that the square of a is in the form of 4q or 4q plus 1. So let's do that. Case 1, when a is equal to 2m plus 0, we have to square the number. So a square becomes 2m plus 0, or you can write as 2m whole square. So it becomes 4m square, which can be written as in the form 4 into m square plus 0, that is 4q plus 0, where q is equal to m square. That is a integer. So we have got our first case and we have got that the expression is in the form 4q plus 0 or 4q. Let us take our second case. Case 2, when a is equal to 2m plus 1, So this implies a square will become 2m plus 1 whole square. Now a square is equal to, we will use a plus b whole square, that is a square plus 2ab plus b square. So 2m whole square, that means 4m square plus 2ab, 2 into 2m into 1, that is 4m plus 1 square, that is 1. So this is our a square. Now what we have to do? We have to take 4 common out of these two terms. So it becomes 4m square plus m and plus 1. Now this can be written in the form 4q plus 1, where q is an integer and it is equal to m square plus m. So students, you can see here we have got the form 4q plus 1. So we can say that any positive integer, when we square it, it should either be in the form of 4q or in the form of 4q plus 1. So we will write our statement. So we can conclude that any positive, I have to write that square of any positive integer is of the form 4q or 4q plus 1, where q belongs to z, that is set of integers. Thank you.